Now welcome back to our post 1 tutorial. Now today I'm going to lead you to what we call the piecewise function. Now don't forget, in the previous video I have talked about the explanation to a continuity. When we say a function is continuous at a particular point and it's supposed to satisfy some 3 conditions. Yes, I have talked about the first one is f of a. If you're looking for a function being continuous at a particular point, s is equal to a. Now the first condition is that the f of a should be defined. 2, the limit of f of s where s is approaching the particular value a should exist. And I went on to explain that when we say a function is exist, then it means that the limit approaching that specific value a from the left supposed to be the same as the limit of the function where s is approaching that specific value a from the right. Then the last one is the limit of s where s approaching a should be the same as the function f of a, and that is what I talk about. Now then I made a specific explanation that when it comes to the when it exists, we have to always express that one in a piecewise function. Yes, in a piecewise function. Now this one is a critical example of a piecewise function. Now when a function f of s is defined in this particular way, we have f of s being defined in 3 ways. Now this is the first way, the second way, and then the third way. And this one is defined in the form of pieces. That is why we call it a piecewise word function. Piecewise function. Now let's look at this particular thing. Now this one is the actual expression, and this one is the if condition or the condition involved. Now this one means that the f of s is equal to 7x minus 5 if and only if the s is less than what? Is less than 1. So no matter when I'm looking for a situation where I am looking for the function f of s where f of s is any number less than 1, it means I'm going to use this particular thing, this particular function as my f of s. Now when we talk about this one, the second one, the middle one, this one is 3x squared minus x. And then the condition is that the x should be between 1 and 3. Don't forget that when I say s is greater than or equal to 1, it means s can be 1 or can be any number greater than 1. And then this one is s is less than or equal to 3, which means that s is supposed to be 3 or any number less than 3. You get it? And this one means that any number that is approaching here, when s is 1, it means that any number that is approaching x from the left side will fall under s is less than 1. Now this one means that number approaching x from approaching 1 from the right will be a number either equal to 1 or greater than 1. Don't forget when you approximate. Now s is less than or equal to 3 means that the number can be less than or 3 or equal to 3. Yes. Now if you go and watch the first video on limitation, I talked about double limit, one-sided limit, and then two-sided limit. You get it? Now I talked about the two-sided limit when we have a limit of what? F of x where x is approaching a specific number. Now this one is two-sided limit. Now then we talk about one-sided limit. The one-sided limit is one is approaching from the left and one is approaching from the right. Now example, on a Cartesian plane, if I have x here is equal to 2, then I can talk about a situation where a certain number will be approaching these 2 from the left and then approaching these 2 from the right. Now when the number is approaching these 2 from the left, then it means that the x is approaching 2 from the left. The left means exponent negative. Yes, the negative here means from the left. I talked about that one in the previous video about limits. Make sure you go and watch. Yes. Now, x is approaching 2 from the left. It means that this number is supposed to be, the x supposed to be less than what? Less than 2. So anytime x will be approaching 2 from the left, then it means s supposed to be less than what? It's supposed to be less than 2. It's supposed to be less than 2. Yes. Now, so this one, s is less than 1, it means that the only thing that will favor this particular condition is when I have a limit of f of x where x is approaching 1 from the left, because anytime x is approaching 1 from the left, then the number is supposed to be less than 1. You get it? And then approaching 1 from the left means that just like the 2, we are approaching them from here. Now, when we are approaching it from here, any number here is less than the 2. The same applies to the 1. Any number here will be less than the 1. Now, when it is approaching from the 2, when it's approaching 2 from the right, when it's approaching 2 from the right, this is how we write it. We write x approaching 2 from the right. The right means positive. And don't forget that at this particular right-hand side of s is equal to 2, all the numbers here are greater than 2. So at this particular condition, all the numbers here, they are all greater than what? Greater than 2. So if I talk about x approaching 1, limit of f of x, where x is approaching 1 from the right. From the right is supposed to be what? Any number greater than 1. Any number greater than 1. So if I talk about limit of f of x, where x is approaching 1 from the right, here s is less than 1, it will be numbers less than 1. Less than 1 means that it's going to approach the 1 from the left. Now this one is 1 or greater than 1. Any number greater than 1, any number greater than 1 will be approaching from the what? From the right, because any number greater than 1 is supposed to be here. You get it? Greater than or equal to 1 is supposed to be somewhere here. And somewhere here, it means that we have to approach the 1 from the left. Yes. Now, these two things are very, very important. That is why I'm explaining, because that is what we're going to do in the piecewise what function to determine the continuance and then what discontinuity. I hope you are following. Follow me closely. Follow me closely. So one thing I want you to understand is when we are talking about when it is approaching from the left and approaching from the right, how we can use the piecewise function, the inequality, to identify the particular function we are supposed to use. You get it? Now follow me closely. Now, so with this particular question, we are looking for the first one. We are looking for the first one, I, lim of f of x, where x is approaching 1. Now, at this particular point, x is approaching 1. We don't know whether it is 1 from the left or from the right. You get it? And it wasn't stated in the question. Now, so when we say x is approaching 1, then this one is a double limit or two-sided limit. You understand? Follow me closely. Now, when x is approaching 1, then it means that x is supposed to be approximately equal to 1. Because this one is not from the right or from the left. There is no plus here when you say it is from the right. There is no minus here to say it is from the what? From the left. So when we say element of f of s where s is approaching 1, it means that s will be approaching 1, which means it can be from the left, can be from right, but approximately equal to 1. S will be approximately equal to 1. Now, so what will it be? If I say s is approaching 1, meaning s will be approximately equal to 1, then it means s is equal to 1 is supposed to fall here, because the number here will be s is less than 1. So s supposed to be equal to 1 will be here, because here is any number less equal to 1 or greater than 1. So I'm going to choose this particular function as my f of s. So the whole thing will be limit of what? F of s. Now, since it falls here, because s approaching 1 will be falling here, I'm going to consider this one as my what? The function s squared minus what? Minus x, where s approaching 1. And don't forget that the moment x is approaching 1, it means where we see s, we put 1 there. So I'm going to get lim of what? The way the x is 1 squared minus 1, where x is approaching. Oh, sorry. Now let me continue from here. Now the limit to where you see x, we put 1 there. So we're going to get this 1 minus 1. because the x here is 1. So what I'm going to get? We're going to get 3 minus 1, which is equal to 2. So this one is so simple. So when we are looking for limit of s where s approaching 1, s approaching 1 be s is equal to 1. Yes, and s equals to 1 will fall here. We use this particular function, we substitute the value of x inside, then we are done. Now the second one is limit of f of x where x is approaching 3. Now when s is approaching 3, it means that s will be equal to 3. It is not approaching from the left or from the right. So s is approaching 3 means s will be equal to what? 3. Now when you look at this one will be s is greater than 3. If I draw the Cartesian plane and here is x, any number greater than 3 will be somewhere here. You get it? Will be at the right. And since it will be at the right, it means the limit is supposed to be approaching the 3 from the right. You get it? Now when you talk about this one is s is less than or equal to 3. Any number less than 2 will be limit of s approaching 3 from the left because it is less than 3. Yes, but with this particular one, s is approaching 3. We don't know whether it's from the left or from the right. So as s is approaching 3, it means s will be approximately equal to what? 3. And approximately equal to 3, here will be s is less than or equal to 3. So equal to 3 will fall within here. So I have to look at this particular function, f of s, which is 3s squared minus what? X. So which means you're going to have a limit of what? F of s, which is this one, 3s squared minus x. Now this one is s approaching 3. So when we see s, we put 3, they're going to have what? 3 squared minus x is 3. What are you going to get? You're going to get 9 times 3, we're going to get 27 minus what? 3. What are you going to get? We are going to get 24. So this is the answer. I hope it is very simple. It's very simple, but you need to open your eyes very well, especially when it's approaching from the left approach. Now in the next video, I am going to talk about the same piecewise function, but I'm going to bring a question where will you determine where the piecewise function exists or where it is continuous and discontinuous. See you in the next video. Bye bye.